Hello and welcome to Algebra 2, Chapter 6.6, Finding Rational Zeros. And you do need to remember that a rational number is any number that can be written as a fraction. So what we're looking for here are any zeros or any places that it crosses the x-axis, which are numbers that can be written as a fraction. So what we're going to use is the rational zero theorem. Alright, so it says if our polynomial, which that long thing right there is just our polynomial, has integer coefficients, okay, then every rational zero has the following form. So we're going to say P over Q, where P is a factor of the constant term, which is the one found at the end, and Q is a factor of the leading coefficient, which is found at the beginning. So all the factors of our constant over all the factors of our leading coefficient. And remember, factors are numbers that go into a number. So find all the rational zeros of f of x equals x cubed minus 4x squared minus 11x plus 30. So we're going to start by listing out our factors. So our factors of 30, we're going to have 1, 2, 3, 5, 6, 10, 15, and 30. So there's our factors of 30. And those are all going to be over our factors of our leading coefficient, which luckily really is just 1, and that's nice because then they're just all over 1. Now we do have to do plus or minus all these numbers. So if we say P over Q, our list of rationals is going to be plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1. And so we're going to make this whole list here. And so if we have any rational zeros, it's going to come from that list. And so then remember, a way to check to see if a number is a zero is to put it into our synthetic division. So if we write out our leading coefficients, 1, negative 4, negative 11, 30. And so then one way to do this is just to kind of, okay, let's kind of guess here. What do we think would give us 0 at the end? And so you might pick, let's start with 5. And so remember, we drop the 1, multiply, add, multiply, add, multiply, add. And so then that was just a really good guess because all I did was guess the 5. So we have one rational zero, and it doesn't say we don't have up to 2 more rational zeros because this is an x cubed. So there's 2 ways you can continue. You can continue by synthetic division still, but now you have the equation, we have x squared here plus x minus 6. And so you could make a new list of possible rationals because your list is going to be smaller now. Or you could just go ahead and divide this, right? This is x plus 3x minus 2, in which case our zeros are negative 3 and positive 2. And if you look, negative 3, negative 3, positive 2, they're up there in that list, okay? So our answers, our rational zeros, x is negative 3, 2, and 5. So what happens though if you didn't get this one on the first go round? You could just keep guessing. Or another way to do it is to graph it, and definitely if you have a graphing calculator or if you have a smartphone and you have a graphing app, is to then graph it and approximate those zeros, but then check it using your synthetic division. Alright, so we're going to do the same thing. We're going to find all the rational zeros of x cubed minus x squared minus 9x plus 9. And we're going to start out by doing our factors. So our factors of 9, 1, 3, and 9. So we're going to have a much shorter list this time. Factors of 1, just 1. So if we're looking at p over q, we are looking at plus or minus 1 over 1, 3 over 1, and you could drop the ones on the bottom if you wanted to, and 9 over 1. So you have 6 possible zeros here. And if there's any rational zeros, there might not be any rational zeros. Alright, so let's check with our synthetic divisions. We're going to have 1, negative 9, and 9. And it is just up to you on which one of those numbers do you want to start with. So let's start with 3. So if we do 3, we're going to drop, multiply, add, multiply, add, multiply, add. Alright, and so honestly, I am really just guessing today. So there we go. There's another one that worked. Okay. And again, if the first one you pick doesn't work, just try a different one. So I would suggest, rewriting this. So this is now x squared plus 2x minus 3. And it might be much easier just to factor this. So this is x plus 3, x minus 1. That works, and so this gives us x is negative 3, positive 1, and then we already had a positive 3 from up above. And again, notice all 3 of those are in our list from above. Okay, they should always be. Okay, find all real zeros. So this does not just say rational zeros, this says all real zeros. So as long as they're not imaginary, we can find them. So we're going to start with our p over q. So p looks to have factors of 1, 2, and 4. But this time q has factors of 1, 3, 5, and 15. So when you do p over q, you get plus or minus 1 over 1, plus or minus 1 over 3, plus or minus 1 over 5, plus or minus 1 over 15. So that is the 1 from the p over all 4 from the q. And then we get plus or minus 2 over 1, plus or minus 2 over 3, plus or minus 2 over 5, plus or minus 2 over 15. And then we get plus or minus 4 over 1, plus or minus 4 over 3, plus or minus 4 over 5, plus or minus 4 over 15. Okay, so where do you start? Well, that's a great question. Okay, so I just switched over to my free graphing calculator app, which if you have a smartphone and you don't have a graphing calculator, I think it would be a smart choice for you to download. If you have a graphing calculator, you can go ahead and graph this in your graphing calculator. But if you don't, free graphing calculator app. Okay, so I'm going to just glance at this real quick. Let's see here. This right here would be 1. So this looks to be a half. And it might not be a half. It actually might be a little less than a half. In fact, it very well could be less than a half. But I know that between 0 and a half, it touches someplace. And so we need to find where that someplace is. And a half wasn't even one of our choices. So if we look at the ones that are between 0 and a half, you got these 3 right here. You got these right here. And you got these over here. So really it's just where do you want to start? And so, let's start, let's start with 2/3. So we're going to do 15, negative 68, negative 7, 24, and negative 4. And we're going to see if 2/3 is the right answer. So we're going to drop. We're going to multiply. I'm going to try not to mess up, so I'll use my calculator. There's 10. We're going to add. Negative 58. We're going to multiply. We get negative 38 and 2/3. That's not a good sign. We're going to add. We're going to multiply. Negative 30, I think it's 4/11ths. We're going to add. And we're going to multiply. And that does not give us 0 because we're going to have a decimal there. Alright, so that one didn't work. Let me get rid of that one since I only have so much room here. Alright, so let's go maybe a little smaller. Let's try a 1/5. Alright, so if we drop, we multiply, we get 3. We add, we get negative 65. So this is already looking okay because everything is divisible by 5 here. So then we multiply and we get negative 13. We add and get negative 20. Still nice. Multiply, we get negative 4. Add, we get 20. Multiply, we get 4. Add, and we get 0. Okay, perfect. So a 1/5 is one of our answers. And so now if we rewrite this, which you probably want to do, this is going to be 15x cubed minus 65x squared minus 20x plus 20. And it really still is too big to factor. Alright, so one thing that we want to look at is since we're finding all the zeros, this is essentially equal to 0. So if it's equal to 0, what we can do is we can divide the entire thing by 5. And so that will give us 3x cubed minus 13x squared minus 4x plus 4. And so now if we look at our rational zeros, our list is going to be a lot smaller because we're just going to have 1, 2, and 4 over 1 and 3. So it's plus and minus all of those, but it does make our list a little shorter. And we already found the positive 0, so then really we're looking for a negative 0. And if we look over here, it's a little past a half, because remember this is the 1 mark. So we're a little past a half. Oh, let's see here. 1 over 1 is 1. 1 over 3 is not to a half yet. 2 over 1 we're way past. 2/3 though just passed. So maybe that's what we try. Let's try negative 2/3. So with our new numbers, and in fact, I can't. You could always work off of your last work. So we're going to work off those 15, negative 65, negative 20, and 20. We're going to divide this, we said, by negative 2/3. So we're going to drop. We're going to multiply, which is negative 10. We're going to add. We're going to multiply. We get 50. We're going to add. We get 30. We're going to multiply. We get negative 20. And we're going to add and get 0. Perfect. Alright, so there's another 0. Okay, so now we're down to 15x squared minus 75x plus 30. And it looks like, again, we can divide everything by 5. So we're down to 3x squared minus 15x plus 6 Oh, in which case I guess I could have divided by 15 last time, huh? So let's go ahead and divide by 3 again. And we have x squared minus 5x plus 2. Alright, so that is not factorable. So what we need to do is we need to use the quadratic formula. So let's get a new page going. Okay, so we stopped with x squared minus 5x plus 2 equals 0. And we want to do quadratic formula. So let's do x equals negative b, which will be positive 5, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Which will be 5 plus or minus the square root of 25 minus 8 all over 2. 5 plus or minus the square root of 17 all over 2. That does not simplify any further. And remember, this time it asks for all reals and not just rationals. So there's 2 reals, plus we had the negative 2/3 and the positive 1/5. So those are our 4 zeros for that function. Okay, so here we have another one that says find all of the real zeros. So we're going to start again with our P over Q. So we're going to have 1, 2, 3, and 6 all over 1. And remember, these are plus or minus all of them. And if you want to look at a graph, you could definitely look at a graph. Let me go pull one in for us real quick. Okay, so again, I use my free graphing calculator app, and it really looks like we have a 0 around positive 3. So, if you have the ability, and you can graph it without an app or without a graphing calculator, because remember, all you have to do is make a table, and at least it will help you pinpoint a location. So I'm going to try 3 into 1, negative 7, 10, and 6. Remember to put in missing terms if you have any. Drop the 1, multiply, add, multiply, add, multiply, add. Alright, so 3 is one of our zeros. Leaves us with x squared minus 4x minus 2. And that's not going to factor. So once again, I'll probably just use the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we're looking at 4 plus or minus, let's see here, 16 plus 8 all over 2. Okay, remember you need to simplify the square root before you divide by the bottom. So we're looking at 24. 24 simplifies into 4 and 6. So 4 plus or minus 2 squared is 6 all over 2. Then you can simplify, and it's 2 plus or minus the square root is 6. So there's 2 of our zeros, and our other 0 was 3, and there's all 3 zeros. Alright, we're going to wrap it up today with a word problem. A rectangular column of cement is to have a volume of 20.25 cubic feet. The base is to be square with sides 3 feet less than half the length of the column. What should the dimensions of the column be? Okay, so remember we talked about, whenever you have a prism, which this is a prism, that it's based off of the base. So if we have a square base, if you imagine that as square, then you have these sides of this column that go down to another square. So that's square down there. And whenever you find the volume of a prism, it's the base area times the height. So this says that the sides of the base are 3 feet less than half the height. So if you consider the height h, then these sides of the base are 3 feet less than half the height, so half h minus 3, and they're the same. That's a half h minus 3, because it's a square. So if we plug in what we know the volume, because the volume is 20.25. The base area is a half h minus 3 squared. We're going to take it times itself. times the height. And we need to solve this for h. So definitely the first thing is to work this out. So if we follow our square of a difference theorem, it's going to be a squared, which is going to be 1/4 h squared, minus 2ab, and so ab would be 3/2 h. So if we do 3/2 times 2, I think I'm going to get 3h plus 9. We're going to take all of this times h. So it's 20.25 equals 1/4 h cubed minus 3h squared plus 9h. We want it equal to 0, and we really don't want a fourth in there. So let's multiply everything by 4, and we're going to get h cubed minus 12h squared plus 36h minus, because I'm going to move my 20.25 times 4 to the other side, minus 81 equals 0. And so we have to solve this. And so, you might not have rational zeros, but, a good place to start would be, okay, so what are my rational zeros? Well, the factors of 81, we have 1. I believe we got 3 and 27, so 3, 4 doesn't, 5 doesn't, 6 doesn't, 7 doesn't, I think we just go to 9, 27, and 81. We'll start there. So all of those over 1, and it really is plus or minus all of those, but in the case of the dimension of the height, we're looking for a positive one, and you might very well go to graph it again. So let's graph it and see where we get. So here's our graph of this function, and it really looks like we have one at 9 there. Alright, so if we try 1, -12, 36, -81, and we're going to divide that by 9, drop the 1, multiply, add, multiply, add, multiply, add. Alright, so 9 works. Okay, so x equals 9 is one of our answers. Okay, so your other two, though, because we are going to have 2 more. Let's see here, we're going to have x squared minus 3x plus 9. And what we should probably do is check and see, are these going to be real answers? And so remember, you can use your discriminant just to see if you have a real answer, because if they're real, we need to consider them. So if we do b squared would be a positive 9 minus 4 times 1 times 9. This is going to be 9 minus 36, which is negative 27. So this function here is going to give us 2 imaginary answers, and you can't have imaginary lengths of columns. So 9 is our h that we're looking for. And it does ask what are the dimensions of this column. So this one is 9. Over here, we're going to have half a 9, which is 4.5. 4.5 minus 3 is going to be 1.5. So our column is going to be 1.5 feet by 1.5 feet, because the base is square, by 9 feet. There is the area of our column. All right, I know it's a lot to digest, but let me know if you have questions, and we'll talk about this in class next time. Have a good day.